first we import some library and package, and we download the dataset from Kaggle here and load in. And the date of death, if it's 9999, it means patient is survival, not dead, and we set it to be 1. And if the patient is dead, we set it be 0. And we drop out some not important column, like whether the patient is pregnant or not. It's kind of not necessary column. And replace 97, 98, 99 is unknown or missing information. Replace it to be NaN and drop Na. And we randomly choose some sample. And X is every column except death. And Y, our text variable, is the death or not. And we split the data set to be 80 training set and 20% test set. And this is our evaluate metrics, like accuracy and precision, F1 score, recall. And we have 4 model to comparison. First one is logic regression. And here is the result of logic regression. And SVC, support machine vector. The random state is 42. And the third one is random forest. We said the estimator is 100. Now and random state is 42. And the last one is NLP DNA model. Our activation function is ReLU and add an optimizer. And the max iteration is 1000. And comparison for the result. And let's see the result. We can see the neural network have the highest best recall and best F1 score. Although, because our dataset is highly imbalanced, so we can't take accuracy so seriously. We need to check recall and F1 score. So that's why we choose neural network as our proposed model, due to its superior sensitive and balanced performance, and it offers the best recall and F1 score. And I'm introduce other 3 ablation of neural network. Here is our ablation study. At first, we import some library and install some package. And here we're doing some data preprocessing. Simultaneously, 9999 is mean patient still alive, otherwise beat. And we set it to be 1. And if patient is dead, we set it to be 0. And 97, 98, 99 means it's missing value or unknown. So we change it to NaN and drop out. So next, Y is whether patient is dead or not, and X, the feature is every column except death. Death is our target variable. And go on, we defined our neural network. So we use ReLU as our activate function, and drop out at 0.3 to reduce overfitting. And next, we defined our focal loss. So the alpha can control class weighting, and gamma controls let model focus on difficult sample. And then we decide whether to use SMOTE. Here, SMOTE is synthetically generate minority class sample, and we only apply on training set, prevent bias toward the majority class. And we convert NumPy array into PyTorch tensor. And the optimizer we use Aiden. And here is some definition of recall, precision, inference score, accuracy. So now we split data set is 80% training set and 20% test set, and standardize the data. And we have model A, B, C. A is baseline, is original DNN neural network, no smooth augmentation and no focal loss. But model B only use smooth. We use smooth to augmentation data. And model C is our proposed one. We use smooth and focal loss. And here we can see the result. Our proposed model have very high recall, 0.94, and the highest precision. Model C also have the highest F1 score, and that is why we use Model C, smooth and focal loss to be our proposed model.